Welcome to Physics World Online College, where we explain the concept of physics for you to understand with ease and also pass exams with flying color. In our class of today in Physics 101, we continue with our topic on vectors and scalars. We will look at vector multiplication in today's class. Before I continue, please remember to click the notification bell so that you will be reminded automatically anytime we upload a new class video. Also, share with your friends, comment, and subscribe if you have not done so. In our class of today, we will be looking at vector multiplication, which can be done in two ways. Number one, we have the scalar multiplication of vectors, and number two, we have the vector multiplication of two vectors. Now, we are addressing this first part in our class of today. In scalar multiplication of vector, it can be achieved in two ways. One, multiplying a vector by a scalar quantity, which gives us a new vector. Two, multiplying two vectors to give us a scalar quantity. We call that scalar multiplication or dot product of the two vectors. Let's at least be able to consider this as case 1 and this as case 2. This will be case 3 in a subsequent class. Let's take the first one, case 1, a vector multiplied by a scalar. Let's consider a vector A multiplied by a scalar M. The product will yield a new vector D, which is given as, we say D will be the product of M, that's the scalar quantity, and the vector A. The outcome of the scalar multiplication of this scalar quantity and a vector gives us another vector D. That is, if vector A is AXI, AYJ, AZK, and we multiply it by scalar quantity M, then the vector D, which we say is MA, will be M multiplied by AXI, AYJ, AZK. That will give you that the vector D, the new vector, is M. We multiply all the components. So M will multiply AX, give you MAXI, MAYJ, MAZK. So this is also a vector because the unit vectors in the various directions are also there, telling you that D is a what? Is a vector. We can take example on this. Let's solve that simple example that is there. Solution to example. We are given the vector A to be 2I minus 5J plus 4k. And we are asked to find option A, says find 5a. 5 is a scalar quantity, just a numeric value. So to multiply vector A, that will give us 5 open bracket 2i minus 5j plus 4k. If you multiply out, that will give us 5 times 2 is 10i, 5 times minus 5, that's minus 25j, 5 times 4, that will give you plus 20k. So once again, this is a new vector. That resultant is a new vector. In like manner, option B says for us to find minus 2 times vector A. That will give us, using minus 2 to multiply all the components of vector A, 2i minus 5j plus 4k. So we use the minus 2 to open the bracket. That will give us 2 times 2 as minus 4i, minus with times minus, that will give you plus 10j, minus will multiply plus will give you minus 8k. This outcome is also what? A vector. Then option C says we should find the magnitude of minus 2 times vector A. That is, to find the magnitude of this new vector, we take the square root of minus 4 square plus 10 square plus minus 8 square. This will give us square root of minus 4 square is 16, 10 square is what? 100, minus 8 square is what? 64. If you add to that, that gives you 16 plus 64 is 80, plus 100, that is root of 180. Use your calculator to take the root of 180. Once again, since this quantity is not specified, when I say it's not specified, there are questions we will see later where we will call these quantities or these vectors name. We can call it a velocity, represented as that. In that case, velocity has a unit. You will put meter per second or cm per second, depending on what is given in the question. So in this one, we are just dealing with just a plain vector with no unit specified. So we are adding units as this unit. Good. So this gives you the magnitude of this vector. That's for case 1. So let's consider case 2. In case 2, we'll be looking at scalar multiplication of two vectors. Scalar multiplication of two vectors. Or dot product. You can call it dot product of two vectors, or you call it scalar product of two vectors. So I want you to see that this is different from the first case one we did. Case 1 is using scalar quantity to multiply a vector. That gives you a vector. But this one, you are multiplying two vectors. You are multiplying two vectors together. It will give you a scalar quantity at the end of the day. So we'll consider that later. But let's introduce it this way. Let's consider two vectors A and B multiplying each other. each other. Such that the dot product of A and B can be obtained by A dot B is equal to magnitude of A times magnitude of B cos the angle between them. Take note of this formula, where A, this is magnitude of A, that's magnitude of vector A. This is magnitude of vector B, and then theta is the angle between the two vectors, angle between them. So this equation or formula is very important, as we will use it to also calculate the angle between the two vectors much later. So what we have to do now is to check out something we will need for our further dot product of vectors. Let's establish something. If the angle theta is 90 degrees, cos 90 will give you 0, which means that the two vectors are perpendicular to each other, are mutually perpendicular to each other. What does that mean? If you are asked to show that two vectors are perpendicular to each other, what you have to do is to do the dot product of the two vectors. If the result gives you 0, it means they are mutually what? Orthogonal, or mutually what? Perpendicular to each other. But if the dot product does not give you 0, it means they are not what? Perpendicular to each other. That's the one point you need to take note of here. Then another implication of these two vectors being mutually perpendicular to each other is how it affects the unit vector, which I want you to take note of, because we will use it much later in our scalar product or dot products. If this is J, this is I, and this is K, the angle between I and J is 90. The angle between J and K is 90. The angle between K and I is 90. So they are all mutually perpendicular to each other. So the implication is this: if you do I dot J, or you do J dot K, or you do K dot I will reverse it the other way, which means if you do I dot K, and you do K dot J, and you do J dot I, it will give you what? 0. Take note of that, because the unit direction here are perpendicular to each other, meaning the angle is 90 degrees, and the dot product of I dot J will give you 0 that way. Now, if the angle between the two vectors is 0, if the angle between the two vectors is 0, then cos theta, which means cos 0, will be 1. What does that mean? It means that if you dot I dot I, if you dot j dot j, the two vectors going in the same direction, k dot k, it will be equals to what? 1. So when the two vectors are parallel to each other, they are going in the same direction, the dot product will give you what? 1. It will be a maximum. But when they are mutually perpendicular to each other, the angle between them is 90 degrees, then their dot product will give you what? 0. Please take note of these 2 points, as we will use it in the next class to establish scalar product or dot product. I want to pause at this point, having established some of these points we will use in the next class. Please remember to click that notification bell. I will see you in the next class. Bye.